Hi, my name is Kara Carpenter and I'm co-founder of Teachly. Before starting Teachly, I taught for 7 years in both rural and urban low-income schools. The sad truth is that in most of our nation's classroom, instruction today looks very much like it did 40, 50 years ago. There's a lot of worksheets and busy work, and few students get the opportunity to engage in deep thinking and learning. In my own classroom, I tried to be different. I invented collaborative games and projects, facilitated class discussions, and fostered independent learning. But it was hard, much harder than anything I have done since. And there weren't any products to make that kind of teaching easier. I also knew that my reach as a classroom teacher was limited. All kids deserve great teaching and learning, not just those in my class. So, what did I do about it? I got a fellowship to get a PhD in cognition and learning at Teachers College. I met my co-founders and we started Teachly to bridge the gap between all the great research on how kids learn and the products available in the market. We began applying for grants, and as of today, we've gotten $6 million in grants from the U.S. Department of Education, Institute of Education Sciences, the National Science Foundation, the National Institutes of Health, and private foundations. With that R&D funding, we have created 8 math games, brought 6 partner apps onto our data platform. We have 1.5 million downloads and are being used in schools across all 50 states. Unfortunately, most of the ed tech being developed today looks much like the worksheets and busy work, only now it's online. At Teachly, we help children develop strategies and think flexibly. We focus on great design. In fact, our first app, Atomals, won an Apple Design Award for Outstanding Innovation in Design, one of only 12 apps that year to receive the award. And we do this within engaging game worlds that keep kids playing. So instead of shading one rectangle, you're racing through a 3D world and getting support to develop a deeper understanding. Next, we're going to hear from some teachers and administrators about what they like about Teachly.
Technology has really changed my teaching. I don't think I could go back to not having technology in the classroom. Teachly apps really give the students a 3-dimensional experience into mathematical thinking. It allows them to touch and tap and think and slide different characters, different manipulatives, because it's not about the answers, it's about how you get to the answers.
When I first showed the Atomals app to the first grade teachers, their joy was, oh wow, this app is teaching the same way I teach the kids. The connection is right there for the students. After 1 or 2 sessions, they learn how to tap to get started, how to tap to find their teacher name, tap to find their student name. The students can manage it entirely on their own.
When students use the Teachly apps, they're engaged, they're excited, their face lights up.
It's just so interesting to watch how animated they are about their progress. Not just thinking about numbers and math, but they really feel accomplished.
Teachers often tell me that when they use Teachly, that it's just like another person being in the room with them, so that they have time to work one-on-one while the students are still very successful because they get the immediate feedback.
If I'm not available right at that second, I can say to them, please go on Atomals, please go on Subtractables or Mount Multiplis. And I know that they're getting the foundational skills that they're going to need from these Teachly apps. It's been well thought, well planned, and gives them a variety of tools and skills to use to become mathematical thinkers. That second teacher is right there when I'm not.
Teachers are experiencing a big increase in the demand for accountability. They have to show data that shows whether a student is excelling, student is on grade level, student is struggling. What they're used to is sitting with a student one-on-one while 21 other students are busy and trying to assess that student. And this is doing it constantly for them. they can go on and they can see where a student is on their fact fluency, and they have the data for that, which they wouldn't have otherwise.
Having a dashboard in Teachly definitely sets them apart. It gives you another user experience to dive into. It gives you more information on individual students and individual skills. And with the click of a button, I can see what children have done throughout the day and the skills that they have and the skills that they continue to work on.
Our latest project, Market Bay, is an immersive game economy where kids are buying and selling, crafting furniture, and decorating their apartments. Spanning grades K-5, this app is comprehensive. We're teaching them base 10 in the way we actually use it. You want things? You gotta make them, buy them, figure it out. This world gives them the opportunity to have an apartment and decorate it, to run a store and make financial decisions. Kids love the authenticity and grown-upness of Market Bay, which will keep them immersed in learning and doing math. Here's a sneak peek at some of the apartments the kids are creating. This past school year, we tested the game with students over in East Harlem, and week after week, the kids were psyched to play. This student amassed over $500, which represents hundreds of buying and selling transactions. There are other games where you can personalize, but every piece of furniture you see in this room, every dollar earned, every paint created represents time spent doing math. Let's hear from one of our students about creating paint within this game.
And then I'm going to go into craft. And then, which color should I craft? I like blue, so I'm going to do maybe 23.
You'll notice here the goal is to make 77, and she feels comfortable grabbing the 20-somethings,
Definitely not 50.
but is purposely skipping the 51. 12 is enough.
It's supposed to be 7, 9, 10, 11. Now all I need is 11.
Oh, 11.
And
So she's figured out that she does need one more 1, and originally thinks one more 10.
Or maybe a 21. Yeah, that'll probably do it, a 21.
Oh, not one more 10, 2 more 10s, 21. So she waits.
22, 24, 25, 21. A 21. Perfect.
Oh, and she's able to grab the 21.
Then for
Okay, from that, one of the things that we can tell is that this is a student who's very comfortable with estimating and with adding quantities in order to get up to a sum.
1 after 7, right? My mom knows.
Now she's almost finished with the blue and yellow, so she's focusing on the black. She needs 34.
2 tens, and then 12. I need 14. Oh, so there are some ones. A couple yellow ones. Okay, just what I wanted. 11. No, I need 14. 12.
Now she knows exactly what number she's looking for, 14.
11, 14, 10, 7, 10.
This gives us our first indication of something that she doesn't yet know. So 7 and 7 came out, which is a combination to make 14, but she doesn't recognize it as such.
11, 10, 7, 10, 7. Are they trying to make me use 10s and 7s? Well, that's
She has figured
13
us out a
is
little
the
bit
big
on that one. We are trying to figure out what
Maybe I'll
combination
just
she's
use a
comfortable
10.
with and which
So
combination
they
she's
won't do
not.
it. And then 30. I need 4 now. 4. That's it. 4. I'm done.
Next, we'll take a look at how she can
So
use
what
the
is
paint
going
that
to
she
the
has
puppet?
created in her world.
And then I can decorate. Then I'm gonna take my paint. I have 5 of it. And then you can paint the walls or the floors.
Next, we'll go back and revisit some of those teachers and administrators we heard
We have
earlier.
a rigorous process that we go through to screen software before we decide to either pilot the software or purchase the software. Teachers aren't on their own trying to figure out, is this something that's cute or is this something that's going to be very successful?
Given the limited resources that we all have, it's a very worthwhile investment.
I don't have my own iPad at home, so I'm glad that I get to use an iPad at school, and I really like the animals one. I want to be an engineer.
Welcome to Roboco, a wholesome sandbox game about designing and building robots to serve the needs of squishy, hapless humans in the world of tomorrow. Supported by the National Science Foundation Small Business Innovation Research Program, Roboco is a PC digital robotics kit focused on fostering STEM and robotics interest in grade school learners. As they form hypotheses and build robots to conquer tricky challenges, players will learn about robotics fundamentals and develop critical future-ready skills like creativity, critical thinking, communication, and collaboration. Let's see how it works. Drawing from a vast selection of real-world robotics parts, players snap robots together to perform specific tasks, learning about the process of iteration and design along the way. For example, in this challenge, players are tasked with building a robot that can deliver a sandwich to a table in a restaurant. As you can see, this robot isn't quite up to the task. These moments of constructive failure will guide players to iterate and refine their design. Much better. After refining their design and experimenting with some new strategies, the player has created a capable robot, just like a real roboticist.
All right, so we're here with Jalen Belcher from A STEAM Village. This is a grassroots community initiative that gives students, parents, families, teachers, and educators career and educational pathways. Today we're just talking quickly with Jalen about their experience with using Roboco for learning in their program. So first, let's just start with a quick introduction. Jalen, can you just tell me just a little bit about yourself and your role at A STEAM Village?
Okay, so I am 12 years old. I'm homeschooled, but I would be considered 7th grade now. Inside A STEAM Village, I was a summer camp counselor, and we used Roboco and implemented it inside the summer camp, so I'm going to be talking a little bit about that.
Awesome.
I'm also a part of a bunch of different organizations with A STEAM Village, and it's really cool. So
Very cool, very cool. So, so tell me, how have you used Roboco with your students so far, with the folks at the camp, and how have they responded to it?
So the way we use Roboco, we kind of had everyone download and install it, then we shared our screen, and we kind of assigned different challenges for each different part. So we would go through the sandwich challenge first. We would teach the tutorial all the basics, how to use all the tools and controls. We would show everyone how to do a sandwich challenge, and then they would kind of do it their own way and create new ideas. Like one way I used some hinges, maybe a lifter, and once after I did that, the students started experimenting and I started using pistons and stuff. So that was really cool. And after that, after we went and taught all the basic tools and everything, then we kind of moved into more in-depth challenges. So for example, we would say, we want you to grab this coffee mug from one of the ragdoll characters, grab it and make sure you implement a gear ratio inside your robot. And so we taught them how to do a gear ratio and servos and stuff. And some students made their robot's head turn with a gear ratio, and they grabbed the coffee mug with a claw. Other students, their body turn, their arms turn, kind of as servos. And we've just been introducing different, ideas and stuff. Like we got into a little bit about torque, all-wheel, four-wheel drives. That's some of the most deep stuff that we went into. And we had different videos to support this, to give them a better idea. But Roboco was definitely, so we kind of gave them the tools and how to use the tools, and after that they started doing stuff on their own. So one of our students, actually, after we taught him and he installed Roboco for the first day, I think he had 24 hours the next day we met on the game.
Wow.
So he was really invested into it. And he was making all these different robots. And we have a lot of other students that have, 20 hours. Like I think that one student now has around 100 hours in the game.
Amazing.
But all of our students have been, like, after we gave them the tools and how to do all this stuff, they started, implementing and doing their own thing, creative. They were making like dragon bots, waiter bots, let's say truck, a transformer, and all of these bots, they were able to complete the sandwich challenge and everything else that we asked. We had one of our students that they actually completed every single secret challenge inside the game in sandbox mode, and screenshot of that. So I don't know, it was just a really good way to teach engineering, right? The basics and complexity, because I think the complexity of Roboco and the creativity is up to you. Like, it can be as complex and as creative as you want. It just depends on where you're limiting to. Because everyone's able to make a simple robot, but it depends if you're going to expand and, if you're skilled enough or you learn enough to make suspensions and stuff. So I think it is a really helpful tool in our last week of the summer camp. So
that's great to hear. It's super cool to hear the amount of enthusiasm that people had for it. That's really exciting for us to hear, obviously, as the folks making it. So in your experience, how do you think it compares to a physical robotics kit?
So the difference between a physical robotics kit and Roboco is probably the fact that it's more open to those 5th and 6th graders, right? Because not everyone's going to be able to build a robot, or, I just think it's easier to learn. Like, it's easier to learn motors and servo motors, simulating it, than it is if you actually have a motor and a servo motor and you actually do it in real life. But in real life is good because, it's real. But I think Roboco, it expands because it's just so easy to use and create, a vision of what you want your robot to be. And I also think virtual anything is a little bit better than a real life course. Of course, it depends on what that is. But a virtual flight simulator might be better for a real life flight simulator for, newbies or new people. So.
Sure.
So I think this being virtual is really good. So.
Awesome. And then final question, what do you think the long-term educational potential is for Roboco?
Long-term educational potential. So I think the educational potential is really high because Roboco has the capability to get into really, really deep engineering. And all you need is just have courses around it, or maybe just teach a little bit of the tools about it, and it can go a long way. For example, we went all the way into all-wheel and four-wheel drives, and that's a really complex subject, with drive shafts and everything. and we were able to teach this using Robocode, where normally we wouldn't be able to simulate it, right, or be able to show it. And again, I think Roboco is open to kind of what you want to learn, because like it just depends on like whatever you want to learn, you can learn. It just depends on if you're able to do it. Because you can learn suspensions, you can simulate suspensions, but it depends on the person that's using it if you're able to make the suspensions. But long-term potential, I think it's going to go a long way, because everyone that was actually inside the summer course was super excited for Roboco. That was probably your favorite subject inside summer camp, one of them. And we're still playing Roboco even after the summer camp, right? So I think that's really good if you're still playing something even after school's over. And not only that, but they joined the Discord server and everything, and they're really engaged. And they just like looking at all the other robots that the community made. So awesome. I think it has a lot of potential, and to think that it's still let's see, almost, is it beta or is it out of beta?
We're
yeah.
Yeah, we're approaching alpha now.
Alpha, yeah. So to think that they like that in alpha, I think it has a lot of potential, yeah.
Awesome. All right, well, Professor Jalen, thank you so much for your time today. Those are all the questions we had for you. So yeah, can't wait to see you in Roboco as it continues to mature and come out.
Hi, my name is Clifton Roosevelt, and I'm the CEO and founder of Pocket Lab. Thanks for joining our session today. What we're going to show in this session is me acting as an educator and working with a student, a freshman physics student, remotely to do an experiment where we model the discovery of exoplanets. And we're going to do a hands-on demonstration where I have equipment here in my house and the student doesn't have any equipment, but we can use Pocket Lab and our software, Pocket Lab Notebook, to do a pretty rich hands-on science experiment in the absence of having any equipment that we would normally have access to in our classroom or in a lab. To learn more, visit us at thepocketlab.com and see what we're doing to help in this remote and hybrid learning situation that we're in right now.
Pocket Lab is a wireless sensor to gather data from the world around you. Pocket Lab connects with a single button to a tablet, smartphone, or computer and displays data in real time. In seconds, you can start learning about magnetic fields, acceleration, or temperature, and your data easily integrates with programs like Excel or Google Docs.
Being able to take a Nerf ball, cut it in half, slap the Pocket Lab inside of it, rubber band it together, and then kick it and videotape it was extremely powerful.
These girls spent the last 2 weeks learning computer programming. They're a select group chosen to experiment with Pocket Lab, a physics lab that allows them to expand their coding skills.
I thought it was going to be complicated, but it's actually pretty easy.
Naomi Franklin is 11 years old and about to go into 6th grade. She already has several career paths in mind.
Usually with earthquakes, we use accelerometers to kind of look about how stresses and strains are built up and how they release over time.
I can have my IEP students and my exceptionality students and gifted learners challenge with the use of Pocket Lab. So we build in your video tutorials, we link in things right through your website, and have student produce amazing work within groups.
Lets you bring the concepts into the classroom and for students to learn about concepts in a way that's really different than reading about them in a book or taking a test on them. For example, one of my students said, "Oh, I didn't really understand this effect you were talking about in class until I saw it at work in a sensor."
Can you introduce yourself?
I'm John Paul, and
what grade are you in?
I'm a 10th grader at Bellarmine.
We're live on Zoom, and we're using Pocket Lab Notebook for doing the science data collection and for taking us through our lesson. So I have a setup here that we're going to use for modeling planets orbiting around a sun and how we could discover distant planets. And I know you don't have any of this setup. Most people don't have a record player at home. So, John Paul, have you ever heard the term exoplanet?
I think I've heard it, but I'm not sure what it is.
But just take a guess. What do you think that term might mean?
Like a planet that's maybe far away.
Yeah, exactly. So it's a planet that's orbiting a star that's not in our solar system. So they're very distant, and we're interested in learning more about them. But they're typically difficult to discover and difficult to observe.
Maybe because you can't see them as well because they don't emit light.
Right. Yeah, they're only reflecting or blocking the light from nearby stars, and so they're many orders of magnitude dimmer than the stars that they're near. So if you point a telescope at them, you know, it's clearly, you can clearly see the stars, but the planets that are nearby are very hard to depict. So what we are going to do is, we don't have an observatory handy for us right now, but we're going to try to create a model of how these things work. What do we use models for?
To like replicate what's going on in the real world. I know a lot of models are like much smaller than what's going on in real life. Like a model of a city, you know, if you can put it all on like a table versus, you know, cities much larger.
Right. And in the case of our model that we're going to use, which is over here, the scaling is quite off. So here we have our planet, and then this light bulb is going to be our sun or our star, and you can see they're not that different in size, but that's because of the materials that we have to make this nice and easy. So John Paul has a version of the Pocket Lab notebook activity open on his computer. He's got a student copy, and on the screen, in my screen recording, we have a version we have the teacher version, and I can see everything that John Paul sees. We're gonna take this simulation here, and we're gonna reproduce that here with on our tabletop. So have you ever seen a record player? Have you ever used a record player?
I definitely have never used a record player before.
Okay. And then what we're going to do is we're going to collect data using Pocket Lab. And John Paul, I know you've seen this in person, the light sensor to collect data from this experiment. And I'll get the setup going, and then I'll share my screen. So if we're going to start to collect data from this experiment, how would you like me to set up either the light bulb or the planet or the Pocket Lab?
Well, you might want to start out with putting the Pocket Lab like at a medium distance away from the light bulb, or
Okay.
So maybe a foot, or I'm not sure.
Okay.
I know that I can't see the angle quite.
Yeah.
Maybe a foot away.
And do you see how the data is changing?
Oh, yeah, wow.
So we can try a foot away. Okay. I'll try it on our slow speed.
Okay. And yeah, I can see that the data is definitely changing as that spins around.
Okay. So I'll start to record some data so that you have that later to analyze.
So it seems like every maybe every second or about so, the light intensity will just drop by a lot, by like it looks like 600 LUX.
Yeah, that's lux. That's a measurement of visible light. So I'll stop the data recording. And yeah, like you said, there's this periodic dip in the light intensity. So do you know what that term is if you have something that happens regularly, like regular spacing, the time in between those events?
Maybe a cycle.
Yeah, a cycle. And the time in between events we normally call a period, which we would talk about in terms of time. So in this case, seconds. If you're looking at a planet, it could be days or years. And you can observe here, yeah, that period. Okay, so I'll save this, and then you'll have that to refer to later in the lab report.
Yeah, let's try like maybe doing it manually and like just doing it at like a really slow speed.
Okay. All right. So I'm gonna crank it over there, and I'll start recording some data for us to preserve. Can you see the planet? I know it's pretty bright. That light bulb's pretty bright. Now it's about to go behind the light bulb, and it's coming back around in front again.
Okay.
All right, can you see our recorded data from that experiment?
Yeah.
And how would we compare the cycle time or the period for our experiment 1 versus experiment 2?
Yeah, it looks like the period's a lot longer when we went at a slower speed.
Okay.
And it also looks like the when you go around, it doesn't just drop like to go vertically all at once. It sort of seems to slowly decline.
So how do you think the data would change compared to our first experiments if we had a larger planet here on our record player in our model?
My guess would be that when it probably would dip even lower than it does with a bigger ball, with a bigger planet.
So, okay, so if our small planet is in front of our sun, you might not be able to see it, but it's directly in front of the star. The way we currently have it positioned, we're going from like 1200, 1300 lux, and then down to like 400, 500 lux. That's where our planet would be roughly if we're on the same orbit. And can you see the graph, the change in the graph?
Yeah, the graph is a lot lower now. It's like about 100.
Draw some comparisons or contrast. What seems to be the same or different from this photo and the example that we did?
Yeah, so the same. It seems like when there was the size difference like affected the lowest light intensity. So with the bigger planet, the light intensity seemed to like the minimum seemed to be a lot lower, and when there's a small planet, the minimum seemed to be about not as low.
Yeah, and how about can we see a period in this NASA photo?
It doesn't. I don't see. It looks like it just goes down and then continues. So, I don't. You probably might need a little more time for a period, I guess. So no.
So in a real activity, if we're doing this as part of an assignment, you could answer the questions to all these to all the questions here in the lab report, and you could put in your answer, and then I, as a teacher, would get to see any of this, but we won't make you do that. So if we're going to discover an exoplanet using this method, what does that mean for sort of the orientation of like our telescope and this distant solar system and the planet that we're trying to discover?
Yeah, so it seems like when you're trying to take some of that, find some data, you have to also like figure out how far you are away from the star to see like see like what it affects like how bright the star is and the intensity of the star, and then you have to.
The Pocket Lab is our telescope, and the light bulb is our sun. What happens if we happen to be pointed at a solar system and the orbit's going around like this?
Oh, and then that would be the light intensity might not change at all, maybe.
Yeah. So it seems like we have to get lucky that our planet, our star, and our telescope are in line, that you can see this shadow effect when the planet is transiting in front.
Yeah, I didn't think about that. Yeah.
Yeah. So if we're even like, it doesn't even have to be completely perpendicular, but if it's like a little bit, just a little bit angled, and this is, remember, a giant planet in comparison to our star, we would miss that shadow that it's casting.
That's pretty. Sometimes I hear about like, a planet is discovered far away, but if that means that they're not discovering a lot, then that's interesting. Wow.
Greetings from Music City, Nashville, Tennessee. We're so excited to tell you more about Musology and show you the platform in action.
Musology, it helps you learn in a fun and innovative way. When you don't have fun learning, you don't like to learn and you don't try as hard as you would if you're having fun.
Right now he's working on positive and negative numbers.
Two integers are opposites if they are the same distance from zero, equally far.
I like the videos on here because they help us learn in a fun way. But when it's a video on YouTube, he just sits there and lectures you on it. It's not as fun, and you pay attention more if you're learning in a fun way.
Yeah, the music videos are great because they're accurate, they're factual, they don't water it down at all, which is really great because I know that when I'm watching it that the kids are getting the correct content. It's not, they're just getting pieces that fit into the music video. No, they get the full content, they get the full idea of whatever it is we're learning. They don't leave anything out, so I don't have to worry that, I gotta go reteach this part because it really wasn't in the video. All of the concepts are normally always in the videos, and so that's really great that I can show them the video and know that it's all there and they can rewatch it as many times as they need to. I'm sitting here helping him kind of visualize, and especially with some that are above, below and above sea level questions, I have him try to write it out so we can visualize it because it helps him get a good perspective of what he's doing. What I really like about it is the questions are very realistic and they're not easy either. They're not just like a simple, yes or no question. They're having to use deeper level thinking. And so I really enjoy it because it's actually good math. It's not just something watered down. It's challenging. It gives them a lot of challenges and I have to help them a lot, which is great because that's what I'm there for. I think it's really great for some of the kids that don't love math, but it gives them a fun way to watch a video and then go and do questions, and then if they're stuck, they go watch the video, and so they have something to keep returning to if they're getting confused. There's some of the songs that are stuck in my head, some of the songs that are stuck in some of the kids' heads, and so it's been cool to see them enjoy it. All right, how do we do this one?
So we add -7 to -4, that'd be -11.
Okay.
Then we get 9 minus -11, which would be negative.
Would it be -11 or 11?
Oh yeah, it has to be.
Oh, good, after that,
11.
Okay.
So 9 minus 11 would be -2, and then we do that.
That's our answer, right?
Yeah. So for this school, it innovates the way that the kids learn, but like in any other school, we would do math apps, and it wouldn't be as good and fun as this one.
Yeah. It gives them just a different option, which is great. We want to give them as many options as possible here. We want to give them as many choices as possible, and so this is one of the choices, and a lot of times, I ask them to do it, and everyone has to, but sometimes I give them the choice of working on this or a different kind of app that we use or a different thing, and so they get to choose which one they like best. And so now I have a lot of kids that choose this option because it's more fun and the visuals are nice, and they get to restart and they help each other out. So
and she gives us a different assignment so that we can work on the one that we need to work on the most, the one that would help us the most.
Yeah, it's been really cool to work with some of the kids that get through these pretty quickly, the ones that understand the concepts really well. We've been able to challenge them and give them other videos that we haven't even gone over in class, other concepts that are even 7th grade math. I've given some 6th graders 2-step equations. We don't do that in 6th grade, but they were done with 1 step, and I figured that they needed the challenge, and so it's been cool to be able to give that option without me having to prepare it outside of class. I don't have to go prepare a lesson for 2-step for 6th graders. It's there, and so I can just give it to them. So it's been really awesome to have that option for them. Do you remember what the answer was when we looked at it?
No.
Hit her above our diving board.
And then he went below
0. He went 45 to below 45 from 33.
Yeah.
So he's going to be somewhere here. So what do we think?
So we subtracted 33 from 45.
Yeah, 44, 5 minus 33, and that equals?
12.
12, but what's important about this? It's below 0, so it's negative 12. Good.
Got them all right, but number 7.
You did it.
That's the one we got wrong.
All right.
So at the beginning of the journey, the turtle was 150 feet above sea level.
Okay, I think that's what we got wrong last time.
At the end of its journey, the turtle was 375 feet below.
So we're looking for this, right? We got above, and we got where he is below. We're looking for the difference. So how do we do that when we have negative and positive numbers into play?
We would subtract 150 from 375.
That's what we did last time. So think about it. Remember in our coordinate planes how if they are indifferent, we're going to add the absolute values? It's the same thing with this, actually.
Oh, so we needed the absolute value of 375.
Yeah, because we need to add them because we're trying to just see the distance, and distance is always
X-axis and Y-axis make 4 quadrants, and in this you plot coordinates to find out where a point is using an ordered pair.
So right now we're working on graphing ordered pairs, and I'm encouraging her to graph her ordered pair on the whiteboard and then follow the steps that they tell her to, and then write it. Especially with graphs or coordinate planes, it's really hard, it's really easy to mess up. It's really easy to think in your head you know exactly where you're going and then mess up. So I encourage them to either get graph paper or to get a whiteboard and write it all down so that they can track it, and then I can check their work. All right, so we're at 5 negative 9. Perfect. There's 6 spaces up. Perfect. 2 spaces to the right. So where is our new coordinate?
7 negative.
There you go. Perfect. It's really great because I can go check how many times they reset. And so if I could tell, okay, they've reset it 20 times, they're probably struggling. They might think that they know how to do it, and then they're really struggling, but they're afraid to come ask me. So then I can go check on Musology, and it tells me that they've reset it a bunch of times. And so that's a great feature so that I can help them out and go and be like, hey, it looks like you're struggling, but you're not coming to talk to me. So it's a good thing for the kids that may be a little too shy.
Well, what I like the most is that you can easily, if the teacher would explain it some way that you don't get it, and then you look at the Musology video, then you can see easier and simplified ways that can explain it a little better, but it's still the same way the teacher taught it, just it explains it more to where you can get it.
Repetition is key with math and with many subjects, and so a lot of times I'll teach them something, or I'll start with Musology. There's different orders that I use. Sometimes I start with the Musology video, have them work on that, and then I show them maybe another video that's more of a lecture, from YouTube, Math Antics, something like that, and then I'll teach it to them because repetition is key. Many times that they can hear the information and hear it in different ways, then they'll get it, and so Musology is a key factor into the repetition piece of math, and them getting it over and over again, and allowing them to go back and watch it as many times as they want. and it's easy and they can find it and it's fun and it's hip, you know, it's some music that they normally like, and so it's been a great tool to use. All right, let's do this. Okay, so let's put our point at 2-2. Perfect. You decide to move the point 3 spaces down. So where's that going to end up? So we're going to be at -2. Good. 2 spaces to the right. So where are we at now? Wait, what's first? X or Y? 4. Good job. Perfect. Then we gotta put your parentheses. Yeah.
I think musology is different because, like, you can learn different methods and, you know, you have different challenges to do, like silver, gold, then the blue challenge, and so as you advance in those challenges, it gets harder, and usually it's funner because it's kind of like you get to watch a video and then you get to learn from it. But it gets easier than worksheet because worksheets are just like you have to do it in pencil and like it gets kind of boring and it works your hand out and stuff like that.
All right, so we start at the origin. That was 4 paces west.
If someone's behind you and
perfect. 1 south.
You know what that looks like?
What I would do is maybe even mark what coordinate you're at, because you don't have the grids. It might, you know, you might get lost. So let's make sure we -4, -1. 3 spaces east. -1, -1. 3 paces south. Yes. So where are we at now? That's our new coordinate right now. Good, and then 1 pace east. So what's our new coordinate?
0, -4.
Perfect. You want a high five? Great, good job.
I really enjoy it because it helps me a lot with learning. Like, it tells you easier methods than maybe your teacher might explain it confusing. And then musology can help you because it simplifies everything and helps you learn easier.
Equal sign. Here is the way to solve 2-step equations. Here is the way. The steps are the same. Identify the variable. Then do the opposite to both sides of the equal sign. Use addition or subtraction.
I need my whiteboard.
You need your whiteboard? I got half a whiteboard right here.
And you guys tell me kind of what you're doing, what you're working on.
We're working on 2-step equations right now, and I'm working on a problem right now.
Hold up, yeah.
It's -9x minus 108 equals -108. Let's see.
Do you guys enjoy musology?
I love it, dude. Musology is a good math helper. It helps you learn stuff.
I've learned how to do 2-step equations, and it actually helped me a lot because I struggled a lot.
It's fun. You just see a guy dancing and helping you with math problems.
Musology is dope. I like musology because I get to watch people dance, and it keeps me entertained while I'm still learning. It's dope.